Thread synchronization is a mechanism to control the access of a multiple threads to a shared resources. So when two or more threads try to access a shared resource simultaneously, there can be inconsistent behavior or data corruptions. To prevent this, we use synchronization to make sure only one thread can access the critical section at a time. So why do we need synchronization? So let's take a real world scenario like a bank ATM example. Like imagine two users accessing the same bank account and trying to withdraw money at the same time. So if both access the balance simultaneously and try to withdraw more than what's available, the account might go into negative. So which should not happen, right? So this kind of issues is known as a race condition, and we fix it using synchronized access. So how to achieve a synchronization in Java? So we have multiple ways. We can go with synchronized method, so that if a multiple thread accessing the method, like the first thread will execute it, and it will lock for other thread for accessing those things. Like other thread will go in the blocked stage, and once the first thread completes its task, the other thread will take over it. So it is an example. So you can see I have used a synchronized keyword for a method withdraw. So whenever a thread access it, it will get locked. And for next, once the thread, whatever the thread locked it, completes its execution, then the next thread can access the method. Then we have a synchronized block used when you want to synchronize only part of method. So here I have added synchronized directly to the method, but we can have a block as well and add required resource sources or critical section within that. Here is an example. I will go through this in IDE as well. So here you can see I have created a synchronized block within withdraw method. So whenever thread is created and start simultaneously, means what I am doing is I am just checking whether the balance is more than what the amount is trying to withdraw, then like adding some sleep time, so that the thread will go for a sleep, or it will halt the execution and just withdraw the amount, like deduct the amount from the balance, then show the completed withdrawal and show the balance as well. So if the balance is lesser, then show that like insufficient funds are found. So I will show you like how the execution happen with synchronization and without synchronization from IDE as well. But the concept is like just add a synchronized block within the method. Means you can add to the method, and also you can create a separate block within the method, and rest of, like, let's say if you have other statements, you can add it outside that synchronized block as well. Then we have a couple of other process, like you can add a static synchronization to the method. Like, means let's say if the method is static, you can add a synchronization to that as well. Like it will be synchronized for all thread across all instance. Then we have other concept called locks. So I will make separate video on this, but locks is not using synchronized, but it's other concept. Like you need to add a lock, or you need to unlock and lock before utilizing the resource source. So here you can see before using anything, so we are locking it. Then in the finally block, we are unlocking it. So in this case, like in case of synchronized, so lock happens here and unlock happens outside, like once the braces is completed, like here. So the same case in the method, like synchronization, like sorry, a lock happens here and unlock happens here. So no need to do it manually, like a system will take care. But in case of lock system, so you need to lock before utilizing any resources, and unlock it once you are done with your task. So for best practices of synchronization, keep synchronized blocks as small as possible to reduce contention. Then avoid a nested synchronization, like which can lead to deadlocks. And prefer high-level concurrency utilities like concurrent hash map or executor services. Then use volatile or atomic keyword for single variable visibility when synchronization is overkill. So let's see example in Eclipse. So here's an example which I have shown before. Like I have created two thread and withdrawing amount here. So the current balance is 7,000, and if I try to withdraw 700, it should deduct 700, and the balance should be 300. Then if I try to or if the thread tries to withdraw 500, so it should say insufficient or insufficient funds for the user. So let me execute, means here there is no synchronization. So let's see what happens here. So you can see it's tried to withdraw amount. It says like balance is minus 200 because there is an inconsistency here. Again, if I try to execute, uh, you can see it tried to execute, like it tried to withdraw the second thread first, or it tried to execute the second thread first. So the balance was 500, and again the user to computed it. It's inconsistent. Again, let me execute it. You can see the first got executed and the balance was 300. Again, it is not correct behavior. Now let's add synchronization block. So now you can see user 1 is withdrawing, and there will be a sleep or halt of execution, then amount is deducted and statement is printed here. So you can see 300. Then when the next thread, like once the execution is done, the next thread, that is user 2, tries to access the method, and it checks that okay, balance is less than what we are trying to withdraw. So it will say like insufficient funds for user 2. The same thing, like let's say if I try to execute the first one, same thing happens, like the user 2 withdraw first. So it will try to withdraw from the current balance, that is 1000. The balance will be 500 after withdrawing the 500. Then it will try, means the user 1 tries to withdraw. So then it says like insufficient fund. So you can have a multiple threads here, and again you can try the synchronized blocks and all. So this is how we can achieve data inconsistency using synchronization. So again, with this we have other keyword like volatile, atomic and all. So those things we'll see in future videos. Thanks for watching.